Sir, I am not hearing you. Sir? I cannot hear you, sir. I cannot hear you. I just finished one meeting now. Everything was working okay. But now when I just switch to this one, I cannot hear you. No, sir.
Hello, sir. I can't hear you. I can't hear you. So, for me to continue talking. Oh, hello, then. Hello, good evening. Can you hear me? Yes, I can't hear anyone. So, so that's good. I don't know if our lecturer is hearing us.
I think he's having his mic has problem.
Okay, because I just checked now. It's not muted, so I don't know what's going on at his end.
Because I chat him, I told him that I think his mic has problem because even his instructional video was silent.
Okay. Oh, okay.
Yeah.
Okay.
Because when I check in the dashboard,
so that
because he was trying to communicate when I joined.
Okay.
So I cannot hear him. I text him, then he said that, okay, he cannot hear me. So I just sent him a message that maybe his mic is having problem.
Yes, maybe you need to look into it.
Because if not, I just finished one class now, and look at me now, I'm talking to you, you're hearing me. But his own, it's not like that.
His mic is not even moving at all. His mic is not moving. I'm just checking it from here. It's not moving at all.
Yes.
Maybe you should just log out and start again.
You said?
Maybe you should just restart the class and see how far.
Maybe.
Maybe something can happen because I don't know what is going on. Yeah.
I'm hearing you small, small, sir. Can you hear me, sir? I'm not hearing you now. Yes, I'm hearing you, but the volume is very low. Maybe you try increasing the volume so that maybe I can hear you well. You try increase the volume, sir. Maybe I can hear you well.
Hello. I will try login from my phone. He has logged me in, but it seems they are not there. There's only one person. Hello?
Hello, sir.
Aruna, can you hear me?
Yes, sir, I can hear you, sir.
Okay. Where is Samuel now? Can you get to Samuel?
Samuel has left.
Okay. I had to join through my phone.
Okay.
So you can hear me now. Hello? Hello?
I can hear you, sir.
Okay. I think we need to start.
Okay, sir.
And my name is Hilary Onyeka Abugu. And I'm from UNN, Department of Pure Industrial Chemistry. So here we are. I want to first welcome you to this course, Chem 306, which is the instrumental methods of analysis. So on this course, just hold on. I think I want to start recording the meeting. Yes. On this course, we shall be looking at spectroscopy. If you look at the course page, you find out that I sent the course outline, or what we are going to do for the 8 weeks that we have for the course. I sent the outline, and today we'll be looking at spectroscopic techniques. We'll be looking at spectroscopic techniques, which is a form of analysis. It's a form of instrumental analysis. And the spectroscopic methods, from what we have on the slide, involves the measurements of intensity and wavelength of radiations that is either absorbed or emitted by matter. So this provides the basis for sensitive methods involved in the quantification. So as a facilitator, I'm not supposed to teach, but I find it difficult. I find it difficult to do facilitation, which I've been instructed to do. So I will have to go into detail to some extent in this course. I hope you are still hearing me, Mr. Haruna.
Yes, I'm hearing you.
Okay. So, as we have earlier said, at the end of this course, it's expected that we will be able to explain the meaning of spectroscopy, what spectroscopy is all about. We will also be able to describe the nature of electromagnetic radiations. As you know, when matter interacts with electromagnetic radiation, that is the basis of an instrumental method of analysis, the interaction of radiation with matter. So at the end of the course, you should be able to describe the nature of electromagnetic radiation. You should also be able to describe the interaction of radiation with matter, as earlier said, and be able to distinguish between absorption and the emission spectroscopy. Then finally, you will be able to state the types of spectroscopy that we have. These are the things I expect you to know at the end of this week.
Okay, sir.
Now, I've just finished the objectives. That is what you are supposed to know at the end of the course. Now, what is spectroscopy? What is spectroscopy? From what we have there on the screen, spectroscopy is a technique which is concerned with the study of the frequencies involved when electromagnetic radiation interacts with matter. For instance, if you pass a radiation through maybe a bucket of water, let me use a bucket of water for instance. If you pass radiation through it, what will come out, the amount of radiation that will come out of the bucket will be less than the amount that you impinged on the bucket or the amount of radiation that went into the bucket. This is as a result of what? Absorption of those radiation. Absorption of those radiation by the water inside the bucket. So that's what the basis of spectroscopy. So absorption or emission of those radiation that you impinged on the sample. In this case, the sample. Now, if that is what spectroscopy is all about, then interaction of the radiation you are sending with the matter, which is assumed to be the sample now, what form is it? So radiation is a form of energy which could either be absorbed or transmitted. If you look at a law of thermodynamics, energy cannot be destroyed. And from what we have, the interaction of radiation is in spectroscopy involves transition between the different energy levels of an atom or molecule. It involves what? The interaction of radiation in spectroscopy involves transition between different energy levels of an atom or molecule. You must have of energy levels of an atom. So generally, the absorption or emission of radiation by matter involves the exchange of energy. So to understand the principle of this exchange, it is necessary to know the distribution of energy within an atom or molecule. So the internal energy of a molecule is due to what? The energy associated with the electrons present in an atom. The electrons present in an atom is also associated with the vibrations of these atoms, and as well the rotation of various groups of atoms within a molecule. You know, in a molecule, we have several atoms. So that's basically what happens when you send radiation through a sample. Now let's look at the electromagnetic radiation, what it's all about. You know, we have X-ray, gamma ray, UV ray, infrared ray. All these are what? Different regions. These different regions of the electromagnetic wave. Now, if we look at my next slide, I put it clear. Radiation is a form of energy which has both magnetic and electrical properties. And that is why it is called what? Electromagnetic radiation. So now, if you look at the slide, you see radio wave, which occurs around 10 to power 2 nanometer. If you look at the diagram, then microwave is another region of the electromagnetic radiation. We have the infrared. We also have the visible region, the ultraviolet region, that is the UV region, and the X-ray region. So we also have the gamma ray region. So these are different regions of the electromagnetic wave. Now, let's talk about absorption of radiation. What happens when a sample absorbs radiation? Every molecule or molecular species is capable of absorbing its own characteristic frequency of the electromagnetic radiation. For instance, now, if you prepare 1 molar solution, and send an electromagnetic radiation into that 1 molar solution, and prepare another solution like 10 molar of solution, if you send the same amount of radiation, the amount of radiation that will come out in that of 2 molar and that of the one of 10 molar, they will differ because of what? Concentration of those 2 samples. Because of what? Different concentration. Of course, the one that will have higher concentration, that is the 10 molar, will absorb that radiation more than that one that has less concentration of the reagent. So the higher the number of molecules present in a reagent or sample, the higher the absorption. So that shows you that the number of molecules present in a sample determines the amount of radiation that will be absorbed by that sample. And this is the basis of the Beer-Lambert's law. This is the basis of Beer-Lambert's law. The higher the absorption, the higher the concentration. So we are still going to get to Beer-Lambert's law. We'll talk about Beer-Lambert's law briefly. Now, emission of radiation. When an atom or molecule absorbs electromagnetic radiation, it will result in either electronic or vibrational transition from lower to higher energy levels. Such atom or molecule is said to be in an excited or unstable state. If the atom or molecule loses all or part of this energy as radiation or photons, photons of energy will be emitted, which correspond to the difference between the energy levels involved. Now, if you impinge radiation, electromagnetic radiation on a sample, and the sample tends to vibrate, there will be emission of electromagnetic waves. Now, or molecule or as radiation, photons of energy will be emitted, which correspond to the difference between the energy levels involved. The radiation emitted is of specific frequency and will show up as a bright line if dispersed as a spectrum, just like absorption. Emission could also be atomic or molecular. So atomic emission is displayed by many elements, particularly the metals, which after being excited, either thermally or electrically, emits a discontinuous line spectrum due to transition ending in ground state. Now, when a molecule absorbs energy, it doesn't stay in that state. It moves to another energy level. When it doesn't have energy, it's in a particular state, that is ground state. It doesn't have energy. But when once it acquires energy, it moves from that ground state to a higher energy level. And once it loses that energy, it comes down to its former state, which may be ground state or a lower energy level. Now, what are the types of spectroscopy? You remember one of our objectives that at the end of the course, we should be able to mention some spectroscopic types that we have. On this slide, I listed many of them, like the UV and visible spectroscopy. We have the infrared, that is the IR spectroscopy. We have the nuclear magnetic resonance spectroscopy, X-ray, mass spec, and vibrational spectroscopy, and so many of them like that. Now, spectroscopy is, or spectroscopic method of analysis is a technique. It is a technique which involves the measurement of the intensity of radiation that is either absorbed or transmitted. So in summary, this unit we have learned that spectroscopy is also a technique which involves the study of the absorption or emission of radiation. And the electromagnetic radiation or spectrum covers a long range of radiations measured in units of nanometer. Measured in units of nanometer. Absorption spectroscopy measures electromagnetic radiation that is taken in by an atom or molecule. Emission spectroscopy measures the radiation that is given out by atom or molecule. While spectroscopy could be an electronic or infrared, that is vibrational, and microwave, which is also known as rotational. So now we should be able to answer some questions. You know, as a facilitator, I was not supposed to go into detail, rather to just post to you what you are supposed to know for the week, which I've earlier done. And I went ahead to explain some things pertaining to spectroscopy. So it's now left for you to go back and get the material. I think by now we should be able to have laid your hand on the whole course content involved in MOSIS, which is an instrumental method of analysis. So at the end, I expect you to be able to explain what is meant by spectroscopy. You should be able to distinguish clearly between absorption and emission spectroscopy, and to be able to calculate corresponding energy of a UV radiation having a wavelength of about 250 nanometer. So before I conclude finally, I will need us to ask some questions, as I expect you to have gone through what I have just said before now. So if you have questions, so that we can look at it together, and we prepare for next Tuesday. And I want to urge us, if we can schedule a meeting within the week, it will be of utmost importance, because we don't know when our exam will come up. This facilitation ought to have started before now, but due to one thing or the other, As a new facilitator, I had to go through some training to be able to carry out my facilitation. So, Mr. Haruna, I don't know if you have any question. I can't find Samuel anymore.
I don't have questions, sir, but it's the screen that you are talking about that you are sharing is showing still loading. That's why I just messaged you. I think maybe it's network problem or something. Your
I
screen,
think that
I
should be a
can't
network
see.
problem, but
Yeah.
okay. What happened?
That's
I
why I
think I
just.
uploaded this to the course page. Did you see it in the course page?
Yes, I saw it.
Uh-huh. So
Yes, I saw it.
I
It
don't
was
know if you
there.
can
I
open
will
it in your
go
system
through it.
and go through it. Okay.
Yes, I will go through it, sir.
Okay. In our next class facilitation, what we are going to do is to review what we did the previous week. That is, as you are going, as you are reading and going through the e-library that I uploaded, the textbooks and the rest of them. If you have any question or any clarification, just write them down so that in the next contact, what we are going to do, first of all, we take questions from what we did previously before we now go on to talk about what we have for the day.
Okay, sir.
I think with that, we are good. Then even on WhatsApp, if you have any question, you can just put it on WhatsApp so that I can quickly reply.
Okay, sir. But it's like I observed in the course page, there was a place, I think it's this industrial chemical technology that you are going to take us. So it's like when you are giving the announcement, you made a mistake.
Yes,
it's
I
like
used the wrong course code.
Yes, sir.
I used the wrong course code. I didn't want to change it. I will announce it in the that's facilitation on Thursday. I will announce it that they should ignore the course code. But the course title is right?
Yes, sir.
The course title is okay. That is the industrial chemical technology. So
yes, sir.
just look at the course title, forget the course code.
Okay, sir. And also, sir, if it may be possible, maybe if you can send us a mail, like we will be having our classes also time, so that, because I think that's the reason most of the people have not joined.
Okay, I will do a mail
because
right
some
now.
of the lecturers, some of the lecturers, they used to send us mail.
Okay,
mails.
let me do
so
that.
It will be like, it will be like a reminder, because some maybe they did not visit the course page, so they were not, because it's only one of my colleagues that I know. I just sent her
course
a
page,
message through WhatsApp that the class is. Thank you, sir.
Okay, no problem. Samuel, can you hear us?
Good evening, sir. I can hear you, sir. Good evening, sir.
Okay. Good evening. How are we?
Yes. Very well, sir. How are you doing, sir?
Fine. Did you participate in the facilitation? You were on and off.
Yes. Yes, it was like that. Though I've studied that. This one you did was Unit 1, so I've studied Unit 1 already.
Yeah. Okay. That's good because I uploaded
So I understand
the slide. Okay.
Okay, I didn't check the slide. I checked the course material itself. So, and I've read it just this morning.
Okay. Now the thing we've concluded. If you have any question as you are going through the course material, you can just write it down so that in our next section, what we are going to do is to first of all trash all the previous hits that we may have. That is all your questions in our previous facilitation before we now go on for the new one.
Okay, sir. Okay, sir.
I think
problem, sir. Thank you, sir.
We don't have much to do again. So
thank you so much.
I hope I have the permission to end the class.
Yes, sir.
Okay. See you on Thursday.
Yes, sir. Hello, sir.
Hello.
Yes, sir. Are you still there, sir?
Yes, I'm here.
Okay. I wanted to ask something. I just remember now.
Mm.
The the classes of spectroscopy. I have one here. The electronic spectroscopy is caused by the movement of electron from the ultraviolet to the visible. The vibration is from the infrared region and rotational is from microwave. What about the others? The mass spectroscopy or the other ones? Are these just the three ones that are so that we need to know?
Please repeat your question. It's breaking.
Okay, I said the electronic spectroscopy.
Mm.
Are you with me, sir? Okay, I said that one is from the ultraviolet region.
Okay.
So we have, yes, ultraviolet region to the visible. We have the vibrational from infrared and the rotational from the microwave. What about the other frequencies, like radio wave, the gamma ray, and all of that, gamma region, and all of that? They are
Now,
not needed
if you
for
look
this
at,
photoscopy.
no, all these have their areas of application. Like if you look at the electromagnetic radiation in my slide,
Yes.
if you look at it, we have radio
Okay.
wave, microwave, infrared wave, and in between the infrared wave and ultraviolet wave, we have the visible region. We also have the X-ray
Yes.
and the gamma ray. In between this, we still have,
Yes.
that's where we have the nuclear magnetic resonance. All this depend on what? The regions of the electromagnetic radiation. They all depend on you are dealing with.
Okay.
You understand?
Okay,
They
sir.
all depend on the region you are dealing with.
Yes.
Because you know all these instruments, they're all based on absorption and the emission of radiation.
Yes.
Mhm.
So can we equate because I have two different things. I have types of spectroscopy and I have the classes of spectroscopy. We have ultraviolet or visible spectroscopy. Can we equate it to electronic spectroscopy? Is it the same thing? And we take it for each other
No, they are not the
since
same.
it's the same region and all of that. Okay.
Yes, they are not the same. You know, we have vibrational spectroscopy. That is
Yes, that
when
one is
the
from
molecule,
infrared.
yes, from the infrared. Then we also have
Yes.
the rotational. All these depend on the movement of the electrons in an atom. Determines which type of spectroscopy that you are talking about.
Okay, Esa, it's like maybe you didn't get
You
my
understand?
question. Maybe you didn't get my question. In the course material now. Yes, in the course
Yes.
material now, I have types of spectroscopy. They mentioned about 1, 2, 3, 4, 5. About 5 of them. We have the ultraviolet visible spectroscopy. We have the infrared spectroscopy. We have the nuclear magnetic resonance spectroscopy. We have the mass spectroscopy and the X-ray spectroscopy. So later they now mention classifications, which is
Yes,
just three.
into
Electronics.
three categories.
Yes. So I'm not saying that can we equate
Now,
the ones in the one we have the ultraviolet visible spectroscopy, can we equate to electronics since they are in the same region? And infrared spectroscopy, you can equate it with vibrational.
eh,
Are you with me, sir?
hello,
I'm with you. Can you hear
it's
me, sir?
breaking. I can't get you clearly. Can you send as a text?
Hello, Samuel.
Are you on
Yes, I'm with you.
WhatsApp?
Samuel, can you hear
Are
me?
you on WhatsApp?
I can hear you. I can
Are
hear
you
you.
on a WhatsApp
Samuel.
group?
I'm on the WhatsApp group, but it will be long for me to type. But can you hear me? I
Yes,
don't know.
Yes, I can hear you. I think
I
what
can
you are
hear you, but it's
saying,
breaking, so
these
I can't
types,
get
I
all
think
words.
based on the operation, this NMR, IR, and whatsoever that he has listed, that's plenty types. So that one is based on the machine, how
Yes.
it operates. Then those ones, those three that you are talking about, I think that one is based on the reaction. That is the kind of the reaction that the molecule is doing. That ionic vibration whatsoever. That's why he was trying to explain that when it absorbs the light now from the machine, that is those types of the spectrum of light that we have. So the type of the reaction they are classified into that three. That is what I think is trying to explain.
You know,
okay. No problem.
Aruna, Samuel, can you hear me?
I can hear you, sir.
When you are talking, the thing will start breaking. But when Aruna is talking, I will hear him clearly.
It was his voice was also breaking my side too. I was just struggling to hear.
Now, if now I think it's network. What I'm saying
I
is,
think Samuel is having
those
network problem.
categories, the categories that we are talking about is just
yes,
electrons acquire that's a electromagnetic radiation. The kind of movements it makes is what they are trying to classify as categories. While the type of things, that is the region on which all those vibrations are found in the electromagnetic radiation, is what we try to classify as UV, infrared, NMR, mass spec, X-rays, gamma rays. But the kind of movements that each electron makes when they acquire those electromagnetic radiation is where we now talk about the categories.
Yeah, I understand now.
Categories of movements they make. It can be electronic, it can be vibrating. You understand now? So with that, we will see on Thursday.
I understand.
Let me quickly send mail for that Thursday. Thank you.
Thank you so much, sir.
Thank you so much, sir. Thank you.